Good morning, students. Today we are going to discuss about auxin. Auxin is a plant hormone which promotes growth in plants. So basically, it's growth promoting hormone in plants. The existence of auxin was realized as early as in 1887 when Charles Darwin and his son Francis Darwin demonstrated that canary grass, which is have botanical name is Palaris canadensis, coleoptiles, did not show phototrophic response when the tip was either removed or covered with a foil cap. Between 1910 and 1930, investigations conducted by various scientists demonstrated that the agent which perceived light stimulus in phototrophic response was of chemical nature. The first successful isolation of the chemical was carried on in 1926 by a Dutch botanist named F.W. Wendt. He found that oat coleoptile tips contain a chemical which was involved in phototrophic curvature of the coleoptile. The chemical was also involved in endogenous control of growth rates. The chemical, which was called auxin, from Greek language, auxin means to grow by call. Hagensenit and Wendt was later on isolated from a variety of materials including human urine, malt and cornmeal. Now we know that auxins are present in cornmeal in the tissues of all higher plants, although only in small quantities. They are fundamental importance in the physiology of growth and differentiation of plant. The first crystalline auxin was obtained from human urine by Kogel and others in 1934. Chemically, it was shown to be indole 3-acetic acid, which is abbreviated as IAA. Here is the structure of indole acetic acid. We see there is a indole ring which has acetic acid group at third position. Since then, it has been found that indole acetic acid, or we can say IAA, occurs as principal auxin in most of the plant species. There are many other compounds closely related chemically to IAA which also possess auxin-like properties. A summary of some such compounds is here. Name of compound is like indole acetaldehyde, which is discovered by Larsen. Indole pyruvic acid, which is discovered by Yamaki and Nakamura, and indole acetonitrile, this is discovered by Jones et al. In 1952. All have another groups like acetaldehyde, pyruvic acid, and nitrile on their third position of indole rings. Other indole compounds such as methyl 3 acetate, ethyl indole 3 acetate, 4 chloro 3 indole acetic acid, indole 3 acetamide, 4 chloro indole 3 acetic acid, indole 3 ethanol, and indole 3 carboxylic acid also possess Auxins properties. It is believed that most of these compounds, which all have an indole group, are ultimately converted to indole acetic acid. There are also compounds such as phenyl acetic acid present in plants which are not indole and yet possess Auxins activity. However, the chemical nature and physiological significance of their Auxin-like properties are largely unknown. Since more than one type of chemical compound shows Auxin properties, we speak of Auxins rather than Auxin. Bound Auxins. Since the first suggestion of Kenneth Thiamin and Fouquet's Coop in 1940 that the endogenous indole acetic acid may be found to some proteins, the existence of bound Auxins in plant tissues, especially in the seeds, has been demonstrated by many others as well. In bound Auxins, indole acetic acid is covalently linked to a substituent molecule which may be a protein, carbohydrate, or alcohol. In maize kernels, following types of bound Auxins have been detected. First is esters of indole acetic acid. Second is indole acetic acid conjugated with cellulosic glucan. Indole acetic acid and inositol conjugate. Indole acetic acid and myo-inositol glycosides conjugate. Bound Auxins are the storage forms of hormones. They are synthesized during seed maturation and are hydrolyzed during seed germination. These compounds play important roles in establishing the level of free hormones in a plant tissue. Synthetic Auxins. Several synthetic Auxins or chemicals of diverse chemical structure also behave as Auxins. Some examples are phenoxyacetic acid, naphthalene acetic acid, picolinic acid, etc. Most of these chemicals have agricultural applications, generally for purpose other than regulating growth of the plants. For example, 2,4-D or we can say 2,4-D dichlorophenoxyacetic acid is used as herbicide, generally These molecules have structural peculiarities. Structure of some synthetic auxins like 2,4-dichlorophenolic acid, naphthalene. Here is a naphthalene ring with the acetic acid. Beta naphthoxy acetic acid, 2,4,6-trichlorobenzoic acid. Here there is a benzene ring, 3 chlorine on 2, 4 and 6 position and acidic group. Next is 2,3,6-chlorobenzoic acid. Here chlorine groups are on 2, 3 and 6 position of benzene ring. 4 amino 3,5,6-trichloropicolinic acid. So all these are synthetic auxins and some are natural auxins like IAA, IBA, and whereas some synthetic auxins like 2,4-D, NA, all are growth promoting hormones which promotes growth in plants. Some synthetic hormones also used as herbicides to reduce the growth of herbs in cropping fields. So it's just finished. Today we just discuss about auxin nature, its chemical structure, bound auxins and synthetic auxins. So thank you students.